So we take the first question. Crystallization is a better method of separation than precipitation because then precipitation tends to bring other solids out of solution. Crystallization is applicable to all solids and so on. So you need to know the basics of crystallization and precipitation. Crystallization is actually used to purify solids using maybe a cooling method or evaporation method. And crystallization method is kind of very, very slow, but it gives a high purity of crystals. While precipitation is faster, but it gives impure crystals. Okay, it gives impure crystals, but it tends to add other solids or impurities to the final product. So you can use that idea to get the final answer here. So if you check the options carefully, you see that precipitation tends to bring other solids out of solution, which is true. This is true. Then crystallization is applicable to all solids. That's not true. Precipitation always involves salting out. That's also false. Crystallization can be done at high temperatures. No, it can also be done at low temperatures. Okay, cooling or evaporation method. So the only answer is precipitation because it tends to bring out other solids. It brings or leads to the production of impure crystals. That's why the answer is option A. So for the next one, which of the following is not a chemical change? So that means one of these guys is a physical change. That's just the meaning. So let's take them one. The first one is burning of magnesium. Burning of magnesium is Mg. That's when you combine magnesium with oxygen. When you hear combustion, it has to do with combining an element or a compound with oxygen. So you're going to get MgO, which is magnesium oxide. So this is a chemical change because it is very hard or difficult for you to reverse it to the reactant. So this is a chemical change. Then rusting of iron is also a chemical change. Then action of water on potassium. Potassium is a group 1 element. So when you react with water, it gives a valence reaction. So these three are chemical changes. Then obviously this one will be the answer. Okay, dissolving powdered sulfur in carbon disulfide. Carbon disulfide is CS2. That's the formula. Then when combined with sulfur, the sulfur will not react with the carbon disulfide. Okay, the sulfur will just act on its own to be alone. So it will just be like a mixture. So you can actually get the sulfur back by evaporating the carbon disulfide. You heat it up and everything will disappear, then it will remain ordinary sulfur. So this one is a physical change. It's a physical process. So the answer is option D. An important ore of iron contains 72.36% iron and 27.64% oxygen. You have to determine the empirical formula. So you need to write it like this. You write iron. Iron is Fe. Oxygen is O. Then you put the percentage is 72.36. This one is 27. So you divide by the relative atomic mass. Oxygen is 16. Iron is 56. So if you divide this, you're going to get, so I'll give you 1.292. So I'll give you 1.728. Okay, then you divide by the smallest one. The smallest one here is 1.292. So you're going to divide by this one. 1.292. So if you divide this one will give you 1 on this side. While this one will give you 1.337. So the final answer will be Fe. Fe is 1 here, so Fe1 1.33. But you cannot leave the answer like this. Anytime you are doing empirical formula and you are getting anything like 1.33, always multiply by 3. Okay, multiply the final answer by 3. And if you are getting something like 1.5, multiply the final answer by 2. That's just a trick that you can always apply. So to get the final answer to this question, you are going to use 3 to multiply everything. So you just do this one times this one by 3 and times this one 2 by 3. So the final answer will be Fe3O. 1.33 times 3 will give you 3.999, which is 4. So Fe3O4 is the final answer. Okay, so go and check it in the option. So the answer is option C here. That's the answer. Let's check the next one. So for the next question, we are told that which of the following decreases when a given mass of gas is compressed to half its initial volume. Okay, this one is very straightforward. You can use the kinetic theory of gases to get the idea, but just look at the idea. So the given mass of gas is compressed. When you are compressing a gas, it means you are trying to reduce its volume. So the volume was V before. You now turn the volume to V over 2. So it's like the gas was in a very big container before, but you now compress the gas into a very small container. You know, when the gas was in a very big container, they'll have a lot of space between them. And they will take time before they hit the walls of the container. They will move some distance. But now they're not jam-packed together, so the space between them will be reduced and the pressure will increase because they'll be hitting the container very fast because there's no space for them to move. You understand? They are tight. Everything is tight, everything is jam-packed. So you can use that idea to get the answer to this question. So you are told that which of the following decreases. So which of the following will drop? So the first one is average intermolecular distance. So average intermolecular distance, that's the distance between the particles. Will it increase or decrease? Yes, it's going to decrease because in this instant, they were actually far from each other. That's for this one. But now, they are now in a tight corner. They are in a tight space. So they will be close to each other. The particles will be near each other. So this one is true. Frequency of collision. The frequency of collision will increase because they'll be hitting the particles. They'll be hitting the walls of the container more. So the collision will increase. This one will increase, not decrease. So this one is not part of it. Number of molecules present does not affect. Maybe you increase the volume or you decrease the volume. If there are 6,000 particles here, you are still going to have 6,000 particles here. So this one is not affected at all. Atomic radius of each particle, this one too is also not affected. So the only option is option A, which is true. So the answer is option A. Okay. So for this next one, we are told that the densities of two gases, X and Y, are 2.5 gram per dm cube and 10.0 gram per dm cube, respectively. What is the rate of diffusion of X relative to Y? So to solve this question, you use what is called Graham's law of diffusion. It's just a formula. So if you get that formula, you definitely get the answer. So look at the formula here. The rate of diffusion is rho x. Let the first gas be x, rho x over rho y is equals to, then you use the square root of their molecular masses or square root of their densities. You want to put it like that. So if you're using density, it will be dy over dx. Take note of that. So this place is rho x, rho y, but this place says dy dx. It is inverse. Okay, it is inversely related. It's not dx dy. So just substitute that. You can see that dy is 10 and dx is 2.5. So you're looking for the relationship. So just write rho x over rho y. This will be square root of 10 over 2.5. So if you finish this up, you're going to get square root of 10 divided by 2.5 will give you 4. So you're going to get square root of 4. So rho x over rho y is square root of 4. Rho x over rho y will give you 2, or 2 over 1. So the relationship between rho x, or the ratio between rho x and rho y, is 2:1. So you can see 2 over 1, which is 2:1. So you can check the answer there. So 2:1. Okay. Now the next one, properties of the elements are periodic functions of their dash. The properties of the elements in the periodic table are periodic functions of their dash. So the elements in the periodic table, they are not arranged according to the maybe mass number. They are arranged according to the atomic numbers. So when you see the elements in the periodic table, they are arranged according to how the atomic numbers are increasing or decreasing. So that's how they are arranged. So there is the periodic law which states that the properties of the elements are a periodic function of the atomic numbers. So the answer is atomic number. Which of the following solutions containing only hydroxyl ions will liberate hydrogen gas when reacted with magnesium metal? Okay, so you have to look for the solution here which contains only hydroxyl ions. If it contains only hydroxyl ions, then that means the pOH, you have two things. You have what is called pH and pOH. pOH means the number of hydroxyl ions there, the concentration of hydroxyl ions, which is OH minus. So this one is pH. pH is the concentration of H plus, okay, which is the hydrozonium ions, while pOH is the concentration of hydroxyl ions. The total of these two, if you add it together, you must get 14. Total of everything on your pH scale is 1 to 14. Okay, 1 is most acidic, 14 is most alkaline. So what they're asking here in this question, they're just telling you to pick the one that has the highest number of hydroxyl ions, the one that will be most alkaline. That's what they mean. So if you check the option, the answer is option D, because this one is minus 13. So it has enough hydroxyl ions. So the answer is option B. Doing electrolysis of molten sodium chloride. Molten sodium chloride is what is called brine. Okay, molten sodium chloride is called brine. Doing electrolysis of molten sodium chloride, which of the following happens? You need to just try to remember your electrolysis process. Electrolysis is like this. You have an electrolytic cell or a container. Then you have two electrodes here. These electrodes are anode and cathode. So the positive one is the anode, negative one is the cathode. So don't forget that in your NaCl, you have Na plus and Cl minus. This is the chloride ion. This is the sodium ion. So since the sodium ion is plus, it will drift or move to the cathode, where it is going to undergo reduction. It's going to be reduced. Okay, so while the chloride ion will move to the anode, where it's going to undergo oxidation. So take note, oxidation takes place at the anode, while reduction takes place at the cathode. Don't forget that. Oxidation takes place at the anode, while reduction takes place at the cathode. So chloride ions will be oxidized. Okay, they will give out their electrons, then they will become oxidized. We check the options, you're going to see the correct answer. Chlorine atom gains an electron. That's wrong. Chlorine atom is not gaining any electron yet. Chloride ions gains an electron. That's also wrong. You can see when chloride ion gets to the anode, it will give its electron, to give it out. It will not become chlorine gas. It will give its electron out. So the ion is giving out, not gaining. So option B is wrong. This one too is wrong. Chloride ion is oxidized. Yes, that's true, because it's oxidized. Oxidation means giving out of electrons. So chloride ion is oxidized. It's giving out its electrons to become chlorine gas. Sodium ion is oxidized. That's wrong. Sodium ion is reduced, because it goes to the cathode. It will be reduced at the cathode. So the answer is chloride ion is oxidized. So that's the answer, option C. Okay, I hope you understand. Coffee stains are removed with dash. Coffee stains are removed with dash. So you have turpentine, you have borax in water, you have ammonia, and you have kerosene. So borax is a natural mineral compound that has cleaning and bleaching properties, making it useful for removing stains. So the answer is borax in water. A product that is called borax. Borax bleaching agent. I'm going to show you the picture so you can see it is actually used for removing coffee stains in clothes, or very hard, difficult stains that are difficult to remove. Okay, so the answer is borax. Radioisotopes are used for the following except radioisotopes. They're just talking about radioactive elements. What are they used for? So they can be used for generating electricity. That's true. They can be used as tracers. Tracers is when maybe there's a broken pipe and you want to know where the pipe is broken. You can apply a radioactive element there, and the radioactive elements will glow somehow. Okay, to give out some radiation at that particular point. You know that this part is leaking. You can use for radiocarbon dating to know the age of maybe an ancient artifact. Then the next one obviously is development of photographic films. This one's actually wrong. They are not used for development of photographic films. So that's the answer to that question. So for this next question, we are told that in the reaction H3C, that's C triple bond CH plus 2 HBr. HBr is hydrobromic acid. Okay, produces X. They are told that X is what? You have to predict what X is. So this is an addition reaction. This is organic chemistry now. This is addition reaction. So to predict this product X, you have to use what is called Markovnikov's rule. Markovnikov's rule. So this is how the rule is. It's very simple. So to get the answer easily, you have to draw the structure of this compound first. You have to draw it first. So let's draw it first. So this is H3C. So that means you have one carbon and 3 hydrogen like this. Okay. Then you have another carbon beside it. Then you have a triple bond. Then you have CH. You have CH like this. Let me just draw it like this. You have CH. So at this point here, you have HH. So this is the structure of this compound. Now you want to attach HBr to it, 2 molecules of it, 2 molecules of HBr. That's hydrobromic acid. So look at how they're going to do this. It's very simple. This Markovnikov's rule is very simple to use. Look at how to use it. You go to your acid, which is HBr, the hydrogen there, attach it to the carbon atom that has the highest number of hydrogen. Okay, this carbon atom here is C. It has 3 hydrogen. You cannot attach it here. I'll tell you why. This carbon can only form 4 bonds. So if you attach the hydrogen here, you're going to form 4 bonds there. But that means this carbon will not have a way to bond to this carbon again. So that means you cannot attach it to this carbon atom. So you have to attach it to this one that has just 1 hydrogen. So you're going to attach 2 hydrogen here. Just an example. 2 hydrogen will be here. So this bromine here, attach it to the carbon atom that has the least hydrogen, or the one that does not have any hydrogen at all. So this carbon here does not have any hydrogen at all. So you're going to attach 2 bromine to it like this, Br. Okay, so there will not be triple bond again. Everything will not be single bond. So this is how the final answer will be. So you have CH3, okay, which is this part here, CH3. Then you have a carbon and bromine, 2 bromine, that's Br2. So you have CBr2, CBr2. Then the last carbon, C, 1 carbon, then you have hydrogen, 3 of it, CH3, CH3. So just check that in the option, CH3, CBr2, CH3. So you can see that the answer is option A. So that's how to use the Markovnikov's rule. I'm going to post more videos concerning that later. So for number 14, the common characteristic shared by iron and aluminium is that both are extracted by reduction method, form basic oxides, show oxidation state of +2 and 3, and form soluble hydroxide. So let's just check the options one by one, starting from this part. The hydroxides of iron and aluminium are insoluble in water. So this option is wrong. Okay. Then they show oxidation state of +2 and +3. Iron shows oxidation state of Fe2+, and they also have Fe3+. But aluminium is only Al3+. Aluminium does not show Al2+. So that means option C is also wrong. Okay, because you have iron 2 and iron 3. But you only have aluminium as Al3+. So this one is wrong. They form basic oxides. Aluminium forms basic oxide and acidic oxides. Aluminium oxide is amphoteric. So this one too is also wrong. Then they are extracted by reduction method. Yes, aluminium is extracted by electrolysis method. Okay, when you have the cathode and the anode, aluminium drifts to the cathode where it will be extracted by reduction, because reduction takes place at the cathode. Then the ore for aluminium is bauxite. Then for iron, the ore for iron is hematite. So iron is extracted from hematite using carbon reduction or roasting. So the answer is option A. Then for the next one, you have this reaction here. We are told that what happens to the equilibrium constant of the reaction above if the pressure is increased. So you need to know some things about equilibrium constant. Nothing else affects equilibrium constant apart from temperature. It's only temperature increase or decrease that can affect the equilibrium constant, because the equilibrium constant depends on the enthalpy change. So increase in pressure, addition of catalyst, increase in concentration, they do not have any effects on the equilibrium constant K. So if you increase the pressure, you can see in this case, increase in pressure, nothing will happen to the equilibrium constant. The reaction will still be normal. So nothing will happen. Just look for the one that is okay. That's option D. It is unaffected. So I hope you have gained one or two things concerning chemistry. I'll be posting more videos on these topics. More questions will be coming soon. So subscribe to this channel, click the subscribe button, like this video, and share with your friends. Thank you for watching. I really appreciate you for watching up to this point. Thank you. Remain blessed. Peace.